Good morning students. Now today we are going to start our next unit, that is unit 2, and the name of the unit is current electricity, in which chapter 3 comes and its name is also current electricity. So in chapter number 3 or unit 2nd we will study about the current electricity. Now here comes the very first topic, that is topic number 3.1, that is introduction. Here there are 2 points given. In first point it is written, in electrostatics we study the charges at rest, but in this we study charges in motion. As we know that our first unit was electrostatics, so in electrostatics we are studying about the charges at rest, but now in this we will study the charges in motion. Here below it the example is given, that is during lightning electric charges flow from clouds to the earth through the atmosphere. So this is what the movement of the charges or the charges in motion. In the second point it is written, the drift of electric charges in a conductor constitute an electric current in the conductor, which is also similar to the heat flow in a conductor. So here the drift of electric charges, what it constitute, what that constitute an electric current in a conductor, which is also similar to the heat flow in a conductor. If the question comes that what is current carrier, so you can also know the definition of current carrier, that is the charged particle which constitute an electric current in solid, liquids and gases. Yeah, you can say solid, liquid or gases are known as current carriers. So what are current carriers? The charged particles which constitute an electric current in solids, liquids or gases are known as carrier current or current carriers. So in solids the case is different, for liquids the case is also different, and for gases the case is also different. So main thing is that in introduction what we will studying, that we are studying the charges in motion, and what are the current carriers which constitute the electric current are known as current carriers. So this is all about this topic number 3.1, that is introduction. Now the next topic which we are going to start today is topic number 3.2, and the name of the topic is electric current. Now here comes in first point the definition of electric current, that what is electric current or how you can define electric current. So in the first point it is written, it is defined as the amount of electric charges flowing through any cross section of a conductor per unit time is defined as what? Electric current. So this definition is important for your exam point of view, that it is defined as the amount of electric charges flowing through any cross section of a conductor per unit time. If you want to know any another definition, so you can also write that it is defined as the rate of flow of electric charges through cross section of a conductor, or you can say that directly it is defined as the rate of flow of electric charges through any cross section of a wire. So the definition, you should know that what is electric current. You can directly also write that charge per unit time is also defined as electric current. Now how you denote the electric current? It is denoted by I, which is given in the second point. Now in the third point, if we are considering that a charge Q crosses through a cross section of a conductor in time t, then the formula of electric current will become, in the next line the formula of electric current is there, that is electric current which is denoted by I will be equals to total charge flowing, in bracket it is written Q, because Q we are considering the charge which is divided by the time taken, that is a small t. So in the next line in the box the final formula of the electric current is given, that is I equals to Q upon T. So this is the main formula, that I is equal to Q upon T, that is charge per unit time is defined as electric current. Now if you want to convert it in the form of quantization of charge, so in quantization of charge which we have read in chapter number 1, in that chapter we have read that Q equals to NE. So in place of Q you can also write NE. If you want to relate it with quantization of charge, then the formula will become I is equal to NE upon T, where E is the number of electrons, that is charge of an electron, that is 1.6 into 10 to the power minus 19 coulomb. So I is equal to Q by T is the main formula, but with respect to quantization of charge it become I equals to NE upon T. Also one important term you should know, that what is conventional current, as I think so most of the students are knowing that what is conventional current. So the current that flows from a higher potential to a point at lower potential is called what? Conventional current. Now if SI unit of electric current is asked, then the SI unit of current is what? Simply ampere, which is denoted by capital A. So the SI unit of electric current is ampere, which is denoted by capital A. And also we all know that the electric current I is a scalar quantity. So these all things are very important in this topic, that is electric current. So this is all about this topic 3.2, that is electric current. Thank you. If you are having any doubts, then you can directly ask me. Now the next topic which we are going to start today is topic number 3.3, and the name of the topic is electric currents in conductors. So here comes the very first point. As you are seeing the figure here, the motion of the electrons, here it is written free electron, and the part which we have taken is of conductor. So the motion of electrons, let me describe the figure first. So here the motion of the electrons or free electrons in a conductor is randomly. As you are seeing, it is a zigzag manner, so the electron can move in any direction. Now as you are seeing the figure below it, so here on left side the positive charge is there, and on the right side of the conductor the negative charge is there. And as we all know that from positive to negative the electric field lines go, so E vector is denoted by a arrow from positive to negative side, and the movement of the free electrons in a straight line from negative side to the positive side, because electrons is having negative charge, so from the negative charge they are repelled, and towards the positive charge they are attracted. So the random motion can be hampered by the electric field when we apply it on a conductor, because the random motion is converted into a straight line motion. So in which direction the electric field is applied, in the opposite direction the movement of free electrons will be there. Now here comes the very first point. Here it is written, in a conductor free electrons move randomly. I think so it is clear to you. That is in zigzag manner with a thermal speed of the order of 10 to the power 5 to 10 to the power 6 meters per second at room temperature. The random motion of an electron in a conductor is shown in the figure. So this figure I have already described you. In the second point it is written, the flow of net electrons or charge through the given cross section of the conductor is zero. As you all know that the net electric field is also zero, the net charge will be zero, and here also the net electrons through the given cross section of a conductor is zero, hence electric current in the conductor is zero. So if the question comes that what is the electric current or net electric current in a conductor, then directly you have to write zero. Now in the next point or the third point it is written, now let us apply the electric field E vector across the ends of a solid conductor. Connect positive terminal of the battery to one end and negative terminal to the other end of a conductor as shown in the figure. So I think so this figure is clear to you. Left side we have taken the positive terminal, and on the right side we have taken the negative terminal. In the next point it is written, the electric field is set up across the ends from positive to negative end, because always the electric field lines flow from the positive charge and end towards the negative charge. In the next point it is written, the free electrons in the conductor experiences a force, that is F vector equals to minus EE vector in the direction opposite to that of the electric field. Thus free electrons are accelerated in the direction opposite to the direction of electric field. Therefore, there is current in the conductor due to the movement of electrons from negative to positive end. I think so this point is clear to all of you, because when we connect a battery, or you can say when we apply the positive and negative charge towards the two ends of a conductor, then always the electric field lines flow from the positive charge and end towards the negative side, and opposite to this always the electron will flow. So this thing is written in this point number 5. In the sixth point it is written, if the battery is disconnected, the electric current immediately stops, because when we disconnect the battery, again the electric current, how it can flow? It will be stops immediately. The electric current in a conductor exists only for the duration. The electric field exists across the conductor. Therefore a battery provides a steady current in the conductor. So always the what a battery provides the steady current in a conductor, and the next thing is that when we disconnect the battery, then immediately the electric current stops. So this is all about this topic. I think so this topic is also very simple. So this is all about this topic. If you are having any doubts, you can directly contact me. So this is all about the topic number 3.3, that is electric currents in conductors. Now the next topic which we are going to start today is topic number 3.4, and name of the topic is Ohm's law. I think so all the students are knowing Ohm's law, because this thing you have also read in your 10th class. So again we can revise this topic, that is Ohm's law. So here in the first point the definition of Ohm's law is written. Here it is written, according to Ohm's law, the current flowing through a conductor is directly proportional to the potential difference across the ends of a conductor, provided the physical conditions like temperature, pressure, strain, etc. of the conductor remain unchanged. So the main thing is that the current is directly proportional to the potential difference, and here the current which is denoted by I and the potential difference is denoted by V. So in next line the formula with respect to the definition is given, that is V is directly proportional to I, and in the next line after removing the sign of proportionality we will get V is equal to Ri, where R is what, the constant of proportionality and is known as electrical resistance or resistance of a conductor. So simply R is what, a constant of proportionality. So V is equal to IR is the main formula. After cross multiplying it, we can get V upon I will be equals to R. That is also the similar form which is there in the previous box, but the main formula is V equals to IR, where R is what, the constant of proportionality known as resistance. So resistance is what, a constant in V is directly proportional to I. Now also you should know that the value of R depends upon the nature of the material, dimensions and temperature, and it does not depend on the values of V or I. Now as you are seeing the graph of Ohm's law, that it is always a straight line, and in the practical exams you will also perform this practical of Ohm's law, in which you will draw the same graph on the graph paper. So here it is written, for a ohmic resistor the graph between V and I is a straight line as shown in the figure. So on x-axis we have taken V, that is the potential difference, and on y-axis we have taken I, that is what, the current, and the graph between V and I is denoted by a straight line and it is a linear graph. So this is all about Ohm's law, but the main formula is that V is directly proportional to I, or you can say V equals to IR. I think so this topic is clear to all of you, and if you are having any doubts you can directly contact me. So this is all about this topic number 3.4, that is Ohm's law. Now the next topic which we are going to discuss is the subtopic of the topic that was going on, that is Ohm's law. So here comes the next subtopic, that is electrical resistance. So in the very first point the definition is given, resistance of a conductor is the opposition offered to the flow of electric charges in the conductor. So what is resistance? It is simply the opposition which is offered to the flow of electric charge, or you can say that it is defined as the ratio of the potential difference across the ends of the conductor to the current flowing through it, and the formula is there from the Ohm's law, as we all know that V equals to IR. So after cross multiplying it we will get this formula, that is therefore R is equal to V upon I, which is enclosed in a box. And also you should know the SI unit of electrical resistance. The SI unit of electrical resistance is ohm. So the main formula is R is equal to V upon I, and what is the work? It is the opposition offered to the flow of electric charge in a conductor. So this is the SI unit, that is ohm. Also you should know that resistance is measured by an instrument that is known as ohm meter. So if we want to measure the resistance, then we have to use ohm meter, because resistance is measured only by a instrument that is known as ohm meter. So this is all about electrical resistance. If you are having any doubts you can directly contact me. Rest everything is this only. This is all about this topic, that is electrical resistance. Now the next subtopic which comes under Ohm's law is electrical resistivity or specific resistance. So this is also important topic, that is electrical resistivity or specific resistance. So in the very first point it is written that resistivity of a material is equal to the resistance of an object in the form of a unit cube. So what is resistivity? It is equal to the resistance of an object in the form of unit cube. What is unit cube? That is a cube having each side of unit length and made of this material. So this is the definition of electrical resistivity, and the another name of electrical resistivity is specific resistance. Now in the second point the proof for resistivity is given. Here it is written, resistance of a conductor depends upon, number one, it is directly proportional to the length of the conductor, that is R is directly proportional to L, which is shown by equation number 1. In the second point it is noted that it is inversely proportional to the area of cross section of the conductor, that is R is inversely proportional to A, or you can say that R is directly proportional to 1 upon A, which is given here by equation number 2. From point 3 we conclude that nature of the material of the conductor. So from first 2 points we can directly, or from equation 1 and 2 we can directly, after combining equation 1 and 2 we can directly write the formula, that is R is directly proportional to L upon A. Now we have to release this proportionality sign. So in the next line, which is enclosed in the box, after removing the constant of proportionality which is known as specific resistance or resistivity, we have to use the symbol that is rho, because rho is the symbol of electrical resistivity, or you can say that that is specific resistance, or you can say that that is simply resistivity. So in the next line, which is enclosed in a box, that is R equals to rho L upon A. I think so this formula is clear to most of you, and most of the students are also knowing this formula, that is R equals to rho L upon A, because this thing you have also read in your class 10th. So this is the final formula for the resistance, that is R equals to rho L upon A, where rho is the constant of proportionality known as specific resistance or resistivity. So what is rho? It is simply a constant. Directly you can say that rho is the resistivity, and it is used as a constant for R equals to rho L upon A. So this is all about this topic, that is electrical resistivity or specific resistance. But if the SI unit of rho comes, that what is the SI unit of electrical resistivity or what is the SI unit of resistivity, then directly you can calculate the SI unit of rho, that is ohm meter, as the SI unit of resistance is simply ohm. In the similar way, the SI unit of rho is, or the SI unit of resistivity is ohm meter. So this thing you should also know. If you are having any doubts in this topic, you can directly contact me. Rest, this is all about this topic, that is electrical resistivity or specific resistance.
बच्चों वीडियो को लाइक करना, कमेंट करना और चैनल को सब्सक्राइब कर देना, और ज़्यादा से ज़्यादा इस वीडियो को शेयर करना। अगर आपको पता लगता है चैप्टर की PDF नोट चाहिए तो मुझे ईमेल करें।